Go.
Okay, what we have here is we have a series circuit. You need to get up a little bit to see this. We have a 100 ohm resistor, a 75 ohm resistor there, and a 326 ohm resistor here, and then we have a variable resistor here. This is a variable voltage supply, so this will be our battery, which is right here. The orange ones, or red or whatever color they are, those read the voltage across these two resistors. Again, why those two resistors? Because they have a ratio of 2 to 1. The ammeters, as we should know, the ammeters split from here to here, here to here, and here to here with a positive current going into the red probe. That's how they read positive. If you had them mixed up, they would just read negative. Remember that ammeters are always in the circuit, breaking the circuit because they're very delicate. They have to be in with a resistor. Also, we say that an ammeter is in series with a circuit, while a voltmeter is over the top of it. So the voltmeter is in parallel. Let's turn on all of the ammeters first. I'm putting them to 200 milliamps. One of the hard parts about these little meters that we have is that they're not consistent. So I actually had to search for the meters that actually were as close as I could get. Now, that one reads 8.7, 8.8, and 8.7, roughly 8.7, 8.8. So it's probably 8.75. Now that's milliamps. That's not amps. Good Lord. Notice as I up the voltage, 15.3, 15.4 to 15.5, and 15.3. They all went up at the same time. Okay, I turned down the voltage. 6.6, 6.6, 6.6 to 6.7. They all went down at the same time. So we always say that in a series circuit, the current is the same everywhere in a series circuit. That's not to say that it's not the same always. Sometimes kids use those words. They're not the same always. They can change, but you have to change something to make that work. So let's watch that voltage again. Watch what happens as I change resistance. Let me get a little more voltage so we can see it. So I up that to about 12 volts. We have 18.3. I'm going to reduce the resistance. Notice it went up everywhere. I'm going to increase the resistance. It went up, it went down everywhere simultaneously. Because it's one path, it bumps into each other. It can't have a different current somewhere in the circuit, otherwise electrons are being lost. Now let's take a look at these. Okay, these are going to be a little harder. I may have to lift them up. Let's see if we can put that right here. There we go. And I'll put this one right there so that we can see these better. And I'm going to put this to 20 volts. Actually, if I put it right there, I think you can see it better. Can you see them both? Mm-hmm. Okay. Notice that the 150 ohm resistor has almost identical, twice the voltage of the 75 ohm. 2.6, 1.3. I lower the voltage. 1.3, 0.67. Half the voltage. I'll lower it again. 1.5. Let me lift it up again. I'll raise the voltage. And let me lower the resistance. Again, 1.25, 2.47, within tolerances. Twice the resistance will always be twice the voltage. It will always be proportional. Now, the only other thing I have not shown you here, I'm going to take this 326 ohm resistor, or 326 ohm resistor. Let's turn off the voltage. And let's look at the current again. And this should be pretty obvious, but I'm going to do it anyway. I'm going to take and put a jumper across this resistor. So I'm going to short out this resistance. Right now we're at 12 or at 16 milliamps. That one is no longer in the circuit. Notice it jumped up to 36 milliamps because we just took out half the resistance. Well, more than half the resistance. Those combined are about 200 ohms, 225 ohms, and this is 300 ohms. So I've taken out more than half the resistance. Okay, stop please.